ChickSlides, if we look at figure number 48, that shows the primitive streak, which is the mountain. It shows the primitive groove, and it shows the cells moving in. That's bird gastrulation. And figure 49 is actually a slide of that. Figure number 49 is this also. It shows the primitive streak, it shows the primitive groove, and cells moving into that primitive groove. Figure number 52 is basically this, showing how the mesoderm develops and how neurulation occurs in the chick. That's all for figure number 52. Figure number 53 is exactly this, but it's in color. This is in color. In your atlas, it's in black and white. And I think this will help you understand what's in your atlas. If we take a look at slide number 51, here we see a 26 to 29 hour chick embryo. And here again, you could see the whole neural tube forming. And you can see the somites beautifully. When you look at this, and when you look at figure number 51, you know, it's much easy to understand what's going on in figure number 51. And what figure number 51 shows nicely, it shows the whole elongated chick embryo with the somites forming, rather than in this, which is just a section which just shows one somite. Figure number 54 shows the divisions of the endoderm, which we didn't really discuss yet. And as you can see in figure number 54, you have the endodermal tube, which runs along the whole chick embryo. And the endodermal tube starts anteriorly with the pharynx area, then moves to the stomach, then moves to the duodenum, then moves to the small intestine, the jejunum and the ileum, moves to the large intestine, and moves to the cloaca. Something very interesting about the endodermal tube, and that is that there are only 3 places in the body where the endoderm and the ectoderm are in direct contact with each other without the intervening mesoderm. And that's at the mouth, endoderm and ectoderm, and at the anal region, endoderm and ectoderm, and also at the pharyngeal pouches, which are outpocketings of the endoderm, which occur about here. And you also notice in figure number 54 that there are other components of the endoderm that are not just part of the tube. You have the thyroid developing, you have the trachea, which will develop, the liver, the pancreas, and the yolk sac, which is an outpocketing of the endodermal tube. And you have the allantois right nicely here, which is an outpocketing of the endodermal tube. So this is, these color views make it much easier to understand what you see in a figure like figure number 54. And if we move on to figure number 55, which is a 33-hour chick, here you begin to see more differentiation. You begin to see the brain that has its three major components: prosencephalon, mesencephalon, rhombencephalon. Just like in the frog. And you see the heart developing from the splanchnic mesoderm. You see the somites very nicely forming, but you see it in the whole elongated embryo. But when you look at this here, it makes it much easier to understand what's going on. This is just a section through this elongated embryo, which is seen in figure number 55. Now let's look at some cross sections. When we make cross sections through the embryo, like this, that's a cross section. If we look at figure number 61, this is a cross section through the heart. And you can also see that above the heart is the rhombencephalon, the hindbrain. If we move on to figure number 67, that's an older chick embryo, a 50-hour chick embryo. And in this view, again, you can see the somites beautifully. And to understand how they develop, you just have to go back to this. You can see the divisions of the brain. You can see the heart again. In figure number 69, it just summarizes the divisions of the brain. The forebrain, or prosencephalon, is divided into the anterior telencephalon and the posterior diencephalon. Then a little more posteriorly, you have the midbrain or mesencephalon. And then most posteriorly in the brain, you have the hindbrain or rhombencephalon. And that's divided into the metencephalon and the myelencephalon. And then you have the spinal cord. So it's important to know those divisions of the brain. You know, you get those kind of questions on the DAT, the MCAT, the GRE. You know, just know it, basically. Figure number 70, you see a nice scanning electron micrograph, and this was done here at Northridge, that shows some of the brain. And you can see the mesencephalon nicely and the rhombencephalon. You can see the otic pits, which are responsible for hearing. And you can see the ventricle of the heart in this figure. These scanning electron micrographs give some, depth and some helps in understanding what's going on. And then if we look at figure number 75, this is a cross section, but it's done a little more posteriorly, where you can see the spinal cord, where you can see the notochord. This is very similar, actually, to this. You can see the somite, and you can see the hypomere in this, figure number 75. So this drawing here makes it much more easy to understand what's going on really in the living system. Because if you just look at some of these slides, you could sort of say, hey, what is that? But then if you go back to this kind of a figure, you'll know exactly how these structures developed. If we go to figure number 87 and 88, 91 and 92, these are much older chick embryos. These are 3 to 4 days old. Again, you can see the divisions of the brain very, very nicely. You can see the allantoic sac in this one. We have the allantoic sac here. That collects the wastes when the chick is still an embryo. But once the chick is basically hatched, this stuff all gets discarded. And then when the chick starts eating and everything goes on, and then the waste will actually come out through the cloaca, through the anus. Finally, we look at the 4-day chick in this whole mount, showing the extensive circulation that has developed over the yolk. So remember, folks, the chick is different from the frog, and the chick is different from the sea urchin and Amphioxus. Remember, in those cases, in the case of the sea urchin, in the case of Amphioxus, there's very little yolk, but these are very little tiny organisms, and they then eat very, very quickly. In the case of the frog, there's a reasonable amount of yolk, and they use that once they get to the point where it's a tadpole, it's all used up, and then it starts eating. In the chick, however, you have a massive amount of yolk. All we've looked at is the first couple of days of development. These chicks will continue to develop for a couple of more weeks. And during this time, they're using the yolk sac, they're using the yolk circulation, they're using the allantois to get rid of wastes. And once they've used up all of this stuff and got rid of the wastes from development, then when the chick finally hatches, the yolk sac, what's left of it, there's nothing much left of it. It's more or less shriveled up. And the same with the allantois. And then the chick doesn't need these anymore because now the chick eats. And you go through normal digestion and normal removal of the wastes, not through the allantois, but through the cloaca and the anus, just like us. So that's really the story of the chick. And, it's important that we realize that these slides are just the early development of the chick. And I think that the introductory material that I presented in color will really help you understand these early slides and what it's all about.